Hi there, this is Dr. Coring. I wanted to create a little bit longer tutorial that goes over dimensional analysis from the beginning to the end, kind of one whole longer video versus just tiny little types of problems. So first, the benefits of dimensional analysis. It's a method that's very efficient. Once you start doing the same thing every single time with every problem, your time to completion of getting these done is going to be much quicker. So you're going to finish problems faster, you're going to make fewer errors, and dimensional analysis when compared to the other methods such as proportion method or formula methods will cover or work for more problems than those other types of approaches. It's also going to help filter out needed information and eliminate the distractor information. When you have a patient medical record, there's tons of numbers in there. What do you need? What do you not need? This method kind of helps you pull in what you need based on working to get to your stop unit, which I'll describe what that is here in a minute. So the cons of dimensional analysis, it's definitely hard to get the hang of, but once you do, it's kind of amazing. I'm somebody who had a very hard time learning this. I was trying to learn the method of what you need over what's ordered, or, you know, I, I don't even know what it's called, but um, I found this other method that really connects with me, and now I really do enjoy using dimensional analysis. I did say it covers a majority of calculations, but there's just a few that it doesn't. So dextrose dilution problems, those have a couple little steps that are required at the beginning to determine how much dextrose you would add to an IV solution. And there's a tutorial for that in the course tips area that you can watch. Body surface area, that has its own formula. So you have to use that formula to calculate body surface area. And then time to completion questions involve using clock time and determining hours and minutes. So you can't use it, dimensional analysis, for those types of problems from beginning to end. It's very overwhelming if you don't have your common conversions memorized. So prerequisites, memorize your common conversions first. It'll make this much easier. And then get out of the habit of doing mental math. So if you're doing kind of shortcuts and side calculations, that's where the errors usually lie. Don't do that. Keep everything in your whole schematic of your dimensional analysis pathway, and you're going to get much more accuracy in calculating problems. Find the patients to learn it and then practice it. It's going to be worth your time. There's numerous questions that you're going to tackle after this course and every class that you have afterwards. So you do need to know how to do this. All right, so the stop-start method is something that I made up. And what this refers to is what units are you solving for? And the stop unit and start unit are going to kind of be the numerator and denominator, and I'll demonstrate this. So when you're looking for these units, the first thing you can do as a shortcut is look for multiple choice options if that's the case. So if you have a multiple choice question, go look to see what unit is tied onto each of the answer options. That's a quick way that you can plug it in here. If you don't have that luxury, then read the question backwards, because reading from the beginning down to the very last sentence, a lot of times you're going to get distracted or bamboozled into thinking that you need to, go off and do a side calculation over here before you start the problem. But go straight to the last sentence, and that will help increase your efficiency and also get you started on the right path. So in this case, I'm going to go to the very last sentence. And so I see, if given TID, how many milligrams are given per day? So we have milligrams per day. Those are my units I'm solving for. When I'm referring to start unit, that's going to be this unit on the top. And what I mean by that is that's what's going to start my whole cascade of this dimensional analysis. So I'm going to plug milligrams over here and then look for it in the question, but we'll go through that here in a few. When I get to day on the bottom, so when I have day all by itself and I don't have any other types of units down here, that's when I know I can stop, multiply across, and divide by the bottom. Some other things that you should be aware of is looking for code words. And the common code word that people get confused with is if you see how many milligrams should the nurse administer, or how many milliliters should be given. Or so given and administer usually mean dose. So if there was a question that said, how many milligrams should the nurse administer? This would be milligrams per dose. Or how many milliliters should be given? This would be milliliters per dose. All right. Next, with the stop and start units, numbers should not come with those stop and start units. And sometimes you feel like you need to have them, but this problem here is a good example. So we go straight to the last sentence and we see, if given 3 times a day, how many ounces are given over 9 days? So we have ounces and then we have 9 days, but we can't have 9 over here. That ends up being a far more complex question than what I know how to do. So instead, make this 9 days be represented by another word. And this word would define 9 days. So in this case, I'm going to call it maybe course of treatment. I'll say COT. So I know that in this problem, course of treatment equals 9 days. So I'm defining a variable essentially. So instead of 9 days, I'm going to say how many ounces were given in this course of treatment. And then when I have course of treatment down at the bottom, that's when I know I can stop. All right, so next, let's look at this problem here. So we want to identify our start unit in the numerator, and then you go and look for it in the problem. So in this case, we have milligrams given per day. And my start unit is milligrams, so I'm going to put it over here. And then I just look for it in the question. So I see it right here and right here. Which one do I use? So that's our next blunder and tip. If you have more than one unit, there's a couple approaches that you can take. So the first thing would be is to look for your denominator or stop unit that's tied in some way to one of these milligrams and take that one. So, say this was milligrams per dose and up here it's at 150 milligrams per kilogram per dose or something. Then I would know, oh, I want that one because it has the unit I need in it. In this case, I don't see day, but I do see it right here. So the other thing you could do is trial and error. So I'll take this 75 milligrams because it just seems like I should take it because it has just more information. So I'll plug in my 20 milliliters and then I need day and I have milliliters. So that tells me I need to cancel out my milliliters. So I'll put it up here, look for it in the question. And here's where I hit a roadblock. I don't see milliliters anywhere else. So that tells me I took the wrong milligram. It's kind of a roadblock. So I can kind of back this truck up a little bit more here. Okay. And instead I'm going to take the 150. All right. Now the next step is going to be whatever number we pull into the question, we need to then bring kind of its baggage. And that's what I go over here in this step 4, but we'll demonstrate it up here just for some more practice. So again, I'm going to go to the last sentence and I have milligrams per day. We already distinguished from the previous problem, which is the same as this one, that we need to take that 150 milligrams. But we need to determine what baggage it has in the question. So what is it coming with? What is it married to in the question? So 150 milligrams of medication is going to be given via G-tube, has this concentration. So I do see this, remember this code word administer, so this is per dose. That one was kind of sneaky. So I have dose on the bottom, but I need day. So I'm going to place it up here because I need to cancel it out. And now I need to look for something that has dose in it. And it's kind of covert, but this is 3 doses per day. So there's that dose word that I need. So I'm going to pull this in. So we have 3 doses and it's tied to day. So 1 day. That cancels out my dose, and then I have day on the bottom. And so each time after I cancel out, I look and check, am I there yet? And in this case, I am. So I have day, that's all by itself on the bottom. So that's my stop unit. I know I can stop now. And I have milligrams on the top, so now I can multiply across and divide by the bottom. All right, so marital partners or the baggage might not be nice and pretty right next to each other. So sometimes you're going to have to look at a distance for this information. So again, this isn't a multiple choice option, so I'm going to look at my last sentence here, and it actually tells me what I need to solve for, so that's kind of nice. So drops per minute. My start unit is drops. Stop unit is minute. So I'll look for this unit in the problem. I see it right here. So I'm going to pull that 14, and it looks like it is tied to this milliliter. And minutes on the bottom, milliliters here, so I need to cancel out milliliters. So I'll go ahead and place it up here. Look for it in the question, so I can see the 50, but here's the tough part. I see numbers and I'm automatically drawn to that. But if I pull this 100 milligrams over here, I'm going to need to cancel out this milligram. But when I look in the problem, there's no other milligram there. So that tells me I took the wrong marital partner. These ones are kind of a mirage. And actually, what's married to this 50 milliliters is in a completely different location. So it's 30 minutes. So I'm giving this drug. It's 100 milligrams, yes, but 50 milliliters, it's going to be infused in 30 minutes. So now I have minutes on the bottom, and that's what I needed, and drops on the top. So I can go ahead and stop, multiply across, divide by the bottom. All right, this next dilemma, sometimes there's trios as marital partners. So we have multiple units kind of tied together here. So let's see how we would tackle this. I'm going to do the same thing. I'm going to look at my last sentence. What am I solving for? And I have milligrams per dose. My start unit is milligrams. My stop unit is dose. So I'm going to look for milligrams. So I see milligram there and milligram here. So same kind of rule. I'm going to look at my denominator unit. Do either of these have that word in it? And yes, this one does. So that's how I know I need to take this 40. All right. It is married to both kilogram and dose. So we're going to bring both of them. So now we have 2 units on the bottom that we're dealing with, but we need to preserve dose and not cancel it out. So kilograms, we do need to cancel out. So we'll place it up here and look in the question, and I see it right there. So we'll go ahead and put 20 here. And weight and body surface area, so if you have a number that's represented with a meter square, that's body surface area. These guys are bachelors. They're always going to come with just a 1 underneath. So you don't have any baggage coming with those guys. So our kilograms will cancel, and we have just dose on the bottom, milligrams on the top. So this is our stop unit. So we can go ahead and multiply across, divide by the bottom. So in this case, you'll see that we filtered out a distractor right here just by doing this whole schematic. And same thing with this TID. We didn't need that either because we already got to dose here. Sometimes a common error that will happen is students will solve across and then they see, oh, it's TID, and then they'll go ahead and divide by 3. But what you're solving for already is per dose, so you don't need to divide this further based on the frequency. If this were 40 milligrams per kilo per day instead of dose, then you would have day down here, and you wouldn't have been able to stop because you need to get to dose. So in this case, then you would say 1 day, 3 doses, and that would cause you to divide that number by 3. But because we had dose right here, this information was irrelevant. All right. So here's another example. So we have how many milliliters are administered per day if the order reads prednisolone 20 milligrams PO BID. So we kind of had to work a little bit differently. The last sentence did not have the information we needed. It was kind of reversed. So we're going to look at the first sentence here. So we're going to say milliliters, and then I see this administered per day. So it's actually going to be per day. But if we didn't have the per day there, how many milliliters are administered, that would be dose. But because we're given additional information of how much is going to be given in 1 day, then we know the denominator will be day. All right, so my start unit is milliliters. I'll pull that 5. The baggage is 15 milligrams. I need day, but I have milligrams, so I need to cancel this out. And now I'm going to look for 20 milligrams, or not 20 milligrams. I was already jumping ahead in my mind. So 20 milligrams, and this is per dose. So 1 dose is 20 milligrams. Milligrams will cancel out. And then I'm going to check, am I there yet? Nope, I have to keep going. So I'll have to put dose up here and then find it in the question. There's not really anything left other than this BID, which means 2 doses per day. So there's my dose. So I'll pull in 2, 1 day. Dose will cancel out, and then I have day, and finally I'm there. So I can go ahead and multiply across, divide by the bottom to get how many milliliters are given per day. All right, so when I mentioned that you need to have your common conversions memorized, this is an example of why. So we have this problem, amoxicillin, 40 milligrams per kilogram per dose, 3 times a day for a patient weighing 140 pounds. How many milligrams are administered per dose? So again, I'm going to go to my last sentence here. See milligrams per dose. So my start unit is milligrams. Look for it in the question, and I have, just like the previous one, I have 2 units. So which one should I take? I'm going to take this one because it has dose in it, and that's what I needed on the bottom. So we'll do 40 milligrams per kilogram per dose. I need to keep dose there, so I don't need to cancel that out, but I do need to get rid of this kilogram. So now I'm going to look for kilogram in the problem. So this is the next step. If you don't see the unit that you need, is there something in the problem that can bridge you from what you have in the problem into what you need in your dimensional analysis schematic? So yes, pounds, I know I can get pounds into kilograms, but what is that common conversion? So I know 1 kilogram equals 2.2 pounds. So now I can kind of include this as information that's part of the problem. Common conversions are kind of your get out of jail free. You can use them, but they all have to have their own stable definition. So 1 kilogram is 2.2 pounds. So now I kind of go back like, oh, I need kilograms. Where is that kilogram? So I don't see it here, but oh, wait, it's right there. So I'll put 1 here, and the baggage it comes with is 2.2 pounds. So I'm going to bring that with it. That allows me to cancel my kilograms out, but now I'm left with pounds and I need dose. So I have dose over here, so I need to still get rid of my pounds. So now I'm going to look for it in the question, and I have this 140. And remember, weight is a bachelor, so we're just going to place it over a 1. My pounds will cancel out, and now I'm finally to my stop unit here, and I have milligrams on the top, so I can go ahead and multiply across and divide by the bottom. This is a common error actually that people will make, is they see pounds and they see kilograms, and so they'll kind of do this little side calculation of figuring out what the kilograms are ahead of time. But here's where this goes wrong. So if you figure that out, 140 divided by 2.2, it's 63.63 repeated kilograms. So let's say, to make this easy, you just round it up to 64 kilograms. So this is a math error. You're not supposed to round any number until you get to the final number here. So I just pre-rounded a number. That would lead me to a different answer than if I just left it as 63.63 kilograms. If you do this, just make sure that you don't round, but I do highly encourage you just to include it as part of your problem. If you see pounds and you know you have to have kilograms, you're gonna work it out by doing it this way, and you're gonna actually have a more accurate answer, because 63.63, it's actually gonna come with 636363, and that will give you a more precise answer. All right, some other common mistakes is dosing frequency distractors. So let's go ahead and just solve this one. So we need to know, I forgot to put the other part. So we need to know, what is our flow rate, milliliters per hour. So start here. Milliliters is my start unit, so I'm going to look for it in the problem. I see it right there, so we'll pull that. The baggage it comes with is 100 milligrams. We have hours, but milligrams are here, so we'll have to cancel this out. So we have 250 milligrams. And what does it come with? Well, it looks like it comes with every 8 hours. So this is something that happens all the time, and it's very easy to take it because you see that you need hour down here, and that has hour. But this is the same thing as, we'll say, TID, for example. It's just a dosing frequency. It's not that you're going to give this medication over 8 hours. You're actually just doing this every 8 hours. So don't get distracted with this every 8 hours, every 6 hours, whatever it is. So instead, we're actually going to infuse this medication over 45 minutes. So this 250 is actually paired with 45 minutes. So we'll put this over here. That allows us to cancel out milligrams. And we have hour, but we still have to get rid of this minutes. So we'll put this down here and look for it in the problem, which we've already used this. And again, you might get like, well, do I use this? Nope, don't do it. So we don't see anything else. So then remember, our next step is there a common conversion that we can use? Well, I know in 1 hour, there's 60 minutes. So I'll go ahead and include this as part of the problem. So now I can say, oh, there's my minute. So I'll put 60 minutes, 1 hour. My minutes will cancel out, and now I'm at my stop unit of an hour, and I have milliliters over here on the top, so I can multiply across and divide by the bottom. These just take repetition to remember not to use that frequency number there. But it is very easy because you get the unit you need right away, and it kind of deceives you. All right, now this one, amoxicillin. So we're kind of doing the same thing that we did above almost, but we have milligrams per dose. Our start unit is milligrams. So dose is on the bottom. I see milligram here, milligram here. Let's say I took this 400. I'd hit a roadblock because I have milliliters here, and there's no milliliters in the problem, and there's not a common conversion to get out of it either. So that tells me I took the wrong milligram. I can back up, take my 90, and this is a trio, so we have kilograms per day, and both of these need to be canceled out because I need dose. So I'll start with my kilograms. So I see the 30, so we'll bring that in here. And our weight is a bachelor, so we'll just put it over 1. And then we need to get rid of day. So where is day in the problem? So I can see 3 doses per day here. And this is kind of what I was referring to earlier, where if you kind of divide your answer by 3 because you see it's given 3 times a day, that's where the error lies. But in this case, we have milligrams per kilo per day instead of milligrams per kilo per dose. So just by doing dimensional analysis, I keep going until I get dose. So I can put in 1 day is 3 doses. Day will cancel out, and I have doses on the bottom, which is what I need, and milligrams on the top. So I can go ahead and multiply across and divide by the bottom. All right, this is the other common blunder problem that people have trouble with. And we're looking for, it's either tabs per day, per, how many were given, as the kind of problem that you'll see with these. So we have doses that have been taken. So we have a patient that was dispensed 10 tablets and has 3 remaining. So how many doses did they take? And we have a dose of 2 milligrams every 6 hours. So we have to kind of figure some things out first. So we dispensed 10 tablets, but they have 3 remaining. So that means they took 7 tablets. So, oops, I meant to, my brain was already calculating it. So we have 7 tabs that were administered. So again, we're looking for how many doses were given. And then what's our stop unit? So we can kind of come up with a symbol like we did earlier with the course of treatment. We'll just use course of treatment again, just for simplicity. We'll say we don't really know what the course of treatment was. We just know that they had this medication and took a certain quantity. So we'll kind of see how this plays out. So doses are in the top here. So we have dose or doses, if you want to say. So we have to look for it in the question. So we know they took 7 tabs, but that wasn't the dose. The dose is actually defined as 2 milligrams. For whatever reason, our brains want to put 2 milligrams up here because we know that's the dose, but you have to take it a step further and separate it out a little bit more. So we know actually that 1 dose is 2 milligrams. So that is the blunder with this problem, is defining it. So now we can say milligrams up here and look for it in the question. So we have 4 milligrams, and then what is the baggage with that one? So 4 milligrams is how it comes. So it's basically 1 tablet is 4 milligrams. So milligrams will cancel out. I have tablet, but I need to get to this, course of treatment or whatever we're going to call it. So I have tab up here. And then this is where I would say, okay, they took 7 tabs over the course of treatment, whatever duration that was. So now I cancel my tabs and I have my course of treatment on the bottom and dose on the top. So we can go ahead and multiply across and divide by the bottom. All right, last one here. We have how many tabs have been taken. So we'll say tabs. And then our denominator unit is going to be kind of sort of the same thing. We have course of treatment or whatever it might be. So it's not tabs per dose because there's multiple tabs that have been taken. So we just want to see what does that end up becoming. So we need to start with tab on the top and look for it in the question. So this is a little bit different. This is our dose. This is the definition of the tab as what dose it comes as. And then everywhere else we just have milligrams. So I'm going to, again, you want to put 4 milligrams up here, but try to identify when you're doing that and don't do it. So we're defining what a tab is. So 1 tab is 4 milligrams. And then we can kind of carry on here. So we have 4 milligrams. We need to cancel out milligrams. So we have another little calculation we need to figure out. So they were dispensed 40 milligrams and they have 16 milligrams remaining. So we have to figure out how many milligrams were actually taken. So we have to do 40 minus 16, and that'll give us 24 milligrams. All right, so we have 24 milligrams that were given over the course of treatment, it looks like. So now when we're looking at milligrams, we have milligram here and milligram there. So this is a PRN medication. It doesn't mean that they took it every 6 hours. So pulling the 2 milligrams in would be confusing because this is just an as needed thing. We're trying to figure out how many doses they actually took, over a certain duration. So instead, we're going to take 24 milligrams and then over the course of treatment, milligrams cancel, and then we have course of treatment and tabs, so we'll be able to multiply across and divide by the bottom. All right, well that wraps up our long tutorial. Please feel free to check out the course tips area for additional practice exams and tutorials that are shorter in duration, but hopefully this kind of gave you a beginning to end version of dimensional analysis.